Hey guys, welcome. I'm going to go ahead and answer the mechanism on your practice test. I hope this is the question that you've all been waiting for me to answer. Alrighty, so this is an example of an EAS mechanism in which we'll have a hot electrophile with fuming sulfuric acid. And what we mean by a hot electrophile is just the SO3 in reagents. To remind you what our structure of SO3 is going to look like, we get that, okay? A sulfur atom with 3 oxygen atoms double bonded to it. In this EAS reaction, benzene here is almost always going to behave as a nucleophile in the reaction because it's so electron rich. So let's go on ahead and we'll move on to the mechanism itself. Alright, first thing I'm going to do, as always, is just go on ahead, draw out my original products. And from here, I'll try to determine who's going to react as the nucleophile and who's going to act as the electrophile. Okay, if you'll remember what I just said in the slide previous to this benzene molecule here is so electron rich. So it's actually going to act as our nucleophile. And we'll see our sulfur atom here is going to be the one to act as the electrophile. So the very first step of this mechanism is actually seeing a nucleophilic attack at the sulfur. Okay? What that attack is going to do is force one of these double bonds, pair of electrons, to move to one of the oxygen atoms. It doesn't really matter which one, and you'll see why in just a second. But that's what's going to happen. That's our first step. Okay? Alright, here I'm drawing in a positive charge because we lost a set of electrons, and I'm going to draw in what we've added to our molecule. Alright, so we've retained our 2 double bonded oxygen atoms to the sulfur, but we've gained an electron. We have an electron-rich oxygen atom here. So this is where we're going to see our H2SO4 or our H3O plus come into solution. Okay? It's going to come into solution to protonate to get rid of that negative charge. And what we're really trying to do here in this, now that we've added this SO3, is we're really trying to get rid of this negative charge here and this positive charge here. So how we'll do that is we'll just go on ahead and we'll protonate. Alrighty. Okay. So, hope you guys are following along with me here. Alrighty. And at this point, we could just go on ahead and call it SO3H, because that is what we've added to this molecule here with this hydrogen atom there. And I guess if you want to be really technical, there too. Alright, here is where the water that we formed in the previous step of this mechanism is going to come in. It'll act as a base, take the proton to reform aromaticity. Now that's a lot of words, so let me just show you, and hopefully it kind of makes a little bit of sense to you guys. Alright, so it's going to act as a base. We're going to take that proton, and then we're going to reform aromaticity. Okay? So that would look like this. Oops. And we've also, if you'll look right here, we've also reformed H3O plus in solution too, along with our product. All right, that's everything to the mechanism. I hope this really helped you all out. Thanks, guys.